All right, assalamualaikum everybody. I hope you all are doing super well. Let's start off officially with another video covering topical questions from chapter number 1. That one topic which usually a lot of students find difficult, but we would try our best to cover as much as possible. The main goal today would be to solve questions from the 2023 papers. So we'll be starting off from the from the Feb March series, and would be slowly moving towards May June, and would be trying our best to cover up October November session. If not, we're going to see how many questions we can accommodate in this 1 hour. So the first question which we are going to be doing today is basically question number 3A from your chapter from your Feb March 2023 paper set. So let me just paste the picture up here, and I will be writing the year alongside it ताकि आप लोग को उसका भी पता हो रहा हो कि what year are we trying to solve, and I'm slowly going to solve each of them, observe how to do them and all that stuff. So this is basically a Feb March 23. So starting off with this very first question. Now this question is basically testing the concepts related to data conversion, right? So it's saying that a new computer comes with primary and secondary storage. And now this A part of this question is only related to chapter 1. The B part is related to chapter 3. So we will be ignoring all those questions. We will be only focusing upon the content related to chapter 1 today, inshallah. So now it says that data storage is measured using binary denominations, and that we need to complete each conversion. So now if you see, this is sort of this exact same table which I made that day in the class, right? So it's saying like how many bytes, 8 bytes are going to be equal to how many nibbles. So that's a pretty good question. Now, isko karna kis tarah, you first have to identify that, okay, 8 nibble, how many byte, like 1 byte equals how many nibbles? What's the answer to this? 1 byte equals how many nibbles? Any idea? We studied that 1 byte or basically includes 2 nibbles, because no, Hassan, yes, exactly, two, bilkul. It's basically that 1 nibble includes 4 bits, okay? And then we know that 2 nibbles are basically equal to 8 bits. And we also studied that 8 bits is basically equal to 1 byte, right? So this hence verifies that, okay, we basically have we have 1 nibble equal to 4 bits. So because 1 byte has 8 bits, so this means that it's going to constitute 2 nibbles. So because it's going to have 2 nibbles up here, so now we need to see that, okay, if 1 byte is taking 2 nibbles, then you tell me 8 bytes are going to take how many nibbles? It's just going to be multiplied by 8. So 8 multiplied by 2 is basically going to be 16 nibbles. So the answer to the very first part is that it has 16 nibbles in it. So then the second part says basically that there are 512 kibibytes. So 512 kibibytes. And we need to explain कि यार कितनी megabyte बनेंगे. So it's, to be honest, very straightforward. See, but nothing that much of a complex thingy, because we are well aware that 1024 kibibyte is basically equal to 1 megabyte, right? We know this, right? 1024 kibibyte equals to 1 megabyte. And now we are also somewhat aware that this is basically, if I divide this by 2, I get 512 kibibytes. So these are some common notations which once you start practicing, you're automatically going to learn. So it's not that much of a deal. So if I know that half of 1024 is 512, this means that 512 kibibyte is basically equal to half of 1 MB, which is what? 0.5 megabyte. So the answer to the second one is basically 0.5 megabyte. The third one basically says that now we have 4 gigabytes and we need to convert that into megabyte. So now you tell me one thing, 1 gigabyte includes how many megabyte? Guys, quickly in the chat box. 1 gigabyte includes how many megabytes? Quickly. If you guys want, मैं ये भी आप लोग को दिखा देता हूँ. यहाँ से भी you guys can do it. So yeah, we have this table too. How many exactly, Hassan and Ramin? Perfect. Aliza, do remember, I thought, yeah, you joined late, but still, we made this one table in which we discussed that if we have 1024 megabytes, this is basically equal to 1 gigabyte. So the same conversion is being asked up here, that now it's telling us that, okay, bro, I get the point that you have basically 1 gigabyte equal to 1024 megabytes, but the question is not about 1 gigabyte. It's asking for 4 gigabytes. Now, if I have 4 gigabytes, this means I have to multiply this with 4, right? So I would be doing the basic mathematics. It's going to be be 4 fours are 16, 1 goes up there, 4 twos are 8, plus 1 9, 4 0 is basically 0, and this is 4. So you're going to learn that it's going to be 4096 megabytes. And just like that, it's also going to be asking the one last notation जो कि हमने बिल्कुल end में लिखी थी XB byte की. And we are well aware that 1 XB byte basically equals to 1024 PB bytes. So it's the same notation. Even if you look up here, it's following the same cycle. It's like 1024 and then one other. Then 1024 of the other unit equal to one bigger unit. Then 1024 of that unit equal to something even more bigger. But in your course, the smallest element you guys should be aware of is basically bit. And the largest that's going to be tested is basically going to be XB byte. So the maximum it can go is till XB byte. इससे ज़्यादा नहीं आएगा. So that's an easy question which was out there, and you're going to get like 4 marks for this by just filling out these blanks. So we just did this one question. So is this clear, guys, how we solve this question, or are there any other questions? If they're not, so we can then move on. All right, so let's look into this new question here. Okay, so we don't have any questions. That's great to know. Okay, so now let's solve this question. Okay, this is basically a pretty good question because it's testing multiple concepts. It's asking you to give us some definitions, and this is also again from Feb March 2023. So same year, same paper. Now you would have observed that we have basically 2 questions from the same topic. So this means that chapter number 1 is something which the examiner loves testing. So is pe risk nahi lena. So now, just the way I told you guys in class, examiner after 2023 has started asking for definitions. So you guys should be aware of the definition part. Where can you guys find this definition? So basically your hotter education book. That book at the end of a chapter, so like once your chapter ends, I can show this once the class ends too. At the end of the chapter, there is one big box there, and it has all the important key terms alongside the perfect definition. So you don't need to memorize it, but I would recommend go and read it twice. Say 2 to 3 times read karo, and even if you have time, go for the 3rd time. Otherwise, I would recommend, except for the one which are commonly tested on exam, do give a read 2 to 3 times so that you do have some sort of an idea of what it's basically asking. Sir, how 1 nibble equals to 4 bits? I don't get the first part. Okay, Ramin, so basically this is something we have to memorize. So yeah, we studied this one thingy that basically we have a big register, so yeah, a register. And if the register is of how many bits? 1, 2, 3, 4, 5, 6, 7, 8. So it's basically of 8 bits. So we studied that earlier on, that 8 bits is basically equal to 1 byte. Just the way we learned that 8 bits is equal to 1 byte, you also have to learn that when we have a group of 4 bits, so if I like only consider this part, these 4 bits, if I want to give this 4 a group, group of 4 a name, it's basically known as 1 nibble. So 4 bits is basically known as 1 nibble. It's something you have to memorize, that 4 bits equals to 1 nibble. And now when we have 4 bits as 1 nibble, this automatically tells us that if I have like basically 8 bits, which is equal to 1 byte, how many nibbles would it be? It's basically going to be 2 nibbles. And now because I'm aware that 8 bits basically make 1 byte from this convention, I can say that 8 bits is basically equal to 2 nibbles. So 2 nibbles are also going to be making 1 byte. So this is basically this convention which is going to be used. Now the part where you say, sir, how does 1 nibble equal to 4 bits? That is something you have to memorize. So you need to know this beforehand, that basically 4 bits are basically equal to 1 byte. It's not like हमने कोई calculation या कुछ की है. It's the smallest 4 bits are the smallest number of element out there. Say so the smallest data storage, उसको जब आप 4 times करो तो that's equal to 1 nibble. ये याद होना चाहिए. Then after this, like bytes and byte ke baad, you can have a logic based like 1024 and 1024 and so on. But for the initial few figures, you need to memorize it. Now coming to this question, now it's asking us to basically define what's a pixel. 2 marker, they expect us to write 1 point for this and 1 point for this. Now when taking the classes, I defined pixel as something which has the smallest is basically the smallest component you could represent on a image of an image. So I could say a pixel could be 1 square, or maybe the smallest component of a color, or maybe I can also write it, or perhaps the best definition would be that it is the smallest component, the smallest component of an image on a screen, of an image on a screen. on a screen. Remember when we were discussing those color figures, and I was like, okay, bro, you have this big screen, and up here you can divide this into like small boxes, and each of the box has basically a different color. So the smallest box, which could not be further divided, which I gave you guys the example with an atom, that is basically known as a pixel. And now we need to define resolution. So now your resolution basically refers to bilkul Aliza perfect, the smallest unit of a digital image. But it's not necessary that it's only a digital image. It's better to write it that it's the smallest component of an image on a screen. On a screen, the word screen is also somewhat important, because in one other marking scheme I saw the definition as the smallest element represented on a screen. So yeah, so if you want to go with image on a screen, either way you just need to give them the whole image in the right way, so marks will change. So even your point is correct up here. So now the second point, resolution wala, there you need to talk about what's resolution. So remember I gave you the example कि आपके पास एक y axis में line होगी, and then there you have x axis, and you multiply these two to get the total number of screen resolution, right? So resolution refers to the number of pixels in the wide axis by the number of pixels in the high axis. So now in your exam, you can write this as horizontal, but in your marking scheme, it's referred to as wide. And like this upar wali direction, vertical one, that's referred to as high. So if I have to define resolution, I could do it in a way that it is the number of pixels. It is the number of pixels in the wide direction, which basically means horizontal direction. Okay, wide direction by the number of pixels in the high direction. And this term by up here means that you are basically saying that multiply the number of pixels in the up direction with the number of pixels in the horizontal direction. And this is one other tip I would like to give you guys, not only for CS, for all the sciences, at least at O levels, say at O levels or IGCSE level. If you ever forget a definition, a proper definition, if you know the formula to it, like the way I know that resolution might not be exactly this, like you can also write resolution ke liye, it's the number of pixels per cent area, or it could be it is the number of pixel per inch, or it is the number of pixels in an image. All of those are basically correct. But let's say I forgot the definition. So what I'm going to be doing is I'm going to recall ki yaar iska koi formula to nahi tha. So I remember that yes, resolution is basically a number of pixels in x direction multiplied by number of pixels in the y direction. So I'm just going to be writing that in proper plain English, and you're going to observe that okay, examiner is also going to be awarding that. So if you ever forget the definition for a specific term and you know the formula, try to convert that formula into plain English, and you're going to see that in most cases you would be getting marks for it, inshallah. So yeah, so now coming to part B. Now this part B states that we have to deal with calculating file size. And now it's saying that this is, chalo, that's a pretty good question. Yehi ek question that I wanted to discuss with you guys. So it's saying that we have a resolution of 1000 by 1000 and a color depth of 2 bytes. So now before moving, I have one question for you all, because what's the formula? Pehle formula likh lete. Okay, so the formula is basically that you have the resolution, reso multiplied by the color depth. So color depth. Now my question from you all is, what will be the answer of getting multiplying this two? Like as in, what unit will I be getting the answer in? Would it be bit, byte, KB, maybe byte? What will be the unit of multiplying these two figures? Quickly in the chat box, any idea? अभी तक हम जितने, I think megabyte. Why megabyte, Hassan? No, देखो. Remember, जब हम इस concept को, when we were discussing it at the first place, I was referring to one thing. Okay, let me go back to the notes and explain it from this part. I was referring to one thing, that when we have something like, where is it? Okay, yeah. So remember, I said one thing, that when we are basically calculating, no, not because of that. I told you guys one thing, that your answer at the first place is basically going to be found from this keyword bit, byte, yeah, whatever terminology is being used up here, because the question says that you have a 16-bit color image. This means that when you multiply 512 with 512 to get the resolution, and then you multiply it with the number of bits, the answer you're going to get from this calculation would be in terms of bits. But now the examiner expects us to give the answer in kilobytes. So now we need to basically go from bits to bytes and then from bytes to kilobytes. But if you see, how did I get to know that I have the answer at the first place in bits? It's because in the question they clearly mentioned that the color depth is in bits. Like, see, it's written as 16 bits. So this indicates that when I multiply these two, all of them together, the original answer at the first place is basically in bits. And now then from bits, I have to go to bytes and then from to get to kilobytes for this specific question. Now, if I come up here back to the question which I'm discussing up here, you're going to see that in this part, the examiner is saying that you have this as the resolution, but now the color depth is in what? It's in what? It's in the form of bytes, right? It's in bytes. So now if I multiply this with this, the answer of this specific calculation would be in what unit? Now, Hassan, you answer me. What do you think? What will be the answer now? Like in what unit would I be getting the answer? बाइट्स बिल्कुल बाइट्स 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 इट्स गोना बी बाइट्स यू सी यहाँ पे हमारे पास क्या यूनिट है the unit up here is basically bytes, right? So whenever I multiply this with this, the answer which I would be getting is in terms of bytes. Why? Like because आप देखो ये जो आपका फॉर्मूला होता है ना, this formula operates in a way कि यहाँ पे आपने लिखनी होती है रेजोल्यूशन. रेजोल्यूशन को आप मल्टीप्लाई करते हो विद योर कलर डेप्थ. अब जो कलर डेप्थ का यूनिट होगा ना, वट एवर द यूनिट ऑफ कलर डेप्थ इज, अब ये केबी हो या फिर ये आपका बाइट्स हो या ये आपका बिट हो या फिर ये आपका एमबी हो, जो आपका यूनिट का कलर, जो आपके कलर डेप्थ का यूनिट होगा वही आपके इससे जो आंसर आएगा उसका यूनिट होगा. So in this case you will see that yes, now in this case you will see that my color depth is in bytes, right? Bytes. तो जब मैं इसको multiply करूंगा तो the answer which I would be getting, that is also going to be in terms of bytes. And फिर उसके बाद I would be basically either changing the units into something else, or I'm going to be giving that as my answer. So now if I have to plug in the values, you're going to see that the answer is going to be 1000 into 1000. And now I will be multiplying this with 2. But now usually हम क्या करते थे, and if you look at the previous questions, I used to divide this by 8, right? Remember मैं उसको 8 से divide करते थे. Like if I go up here and you look up at this one question, you see that it says that I have a 8-bit color image and this is the resolution and I need to calculate the file size. So I used to divide it by 8. Remember, even though I was getting an answer, let's say in bits, I used to divide it by 8. At this point, we would not be dividing it with 8. Bilkul, Ramin, perfect. Bilkul. We won't be dividing it with 8 because at this point, originally when we divide it with 8, the purpose of dividing this with 8 is basically to go from bit to byte. But you would observe that in this case, the answer is already in terms of byte. Why? Because the color depth is in what? Color depth is in terms of byte. So there is no need to divide by 8 up here. So I'm going to be getting the answer directly as 2 followed by 330. So 1, 2, 3. And then 4, 1 0 0 0 and 0 0. Yep. Yeah. So my answer is going to be 2000000 bytes, and that's going to be my answer. सही है. Now the important point here to note is कि आपने ये गलती नहीं करनी कि यहाँ पे divided by 8, which might be something because in schools students are literally taught that you need to divide it with 8. That's part of the formula. Like I used to think that you have to divide it with 8 either way. But then I observed that you only have to divide it with 8 when the color depth is in bits. So if the color depth is in bits, then you have to divide by 8 so that you could go from bits to byte. But now in this case, I have it directly in bytes. And because the question asked in terms of byte, so my answer yehi hoga. But now if question, let's say I would have asked yaar answer KB mein do. So now this would be in terms of bytes. And now if I had to convert this, isko phir main 1000 se divide karte because it's not KB bytes, it's kilobyte, right? So I would divide this with 1000 and I would get my answer as 2000 kilobytes. And that would be my answer if I had to give it in terms of KB. Now, this is a really important. Can we write this as 2 megabytes? No. Yeah, okay. If I have to convert it from 2000 and if I want to go to megabytes, so megabyte, you are correct. I would further divide it and I'm going to get the answer as 2 MB, which is 100% correct. But you will see that in up here, the examiner clearly wrote the unit as bytes. So now even if you write 2 MB up here, you will be only getting 2 out of 3 marks for it. Why? Because they will be saying that your working sahi hai. You got the correct working, but they expected you to give the answer in what? In bytes. So now if you write 2 up here, it's going to be incorrect because it's not in bytes, it's basically in MB. So they expected you to give answer in bytes. So yes, so इसलिए आपने जो यहाँ पे लिखा होगा, you need to write it in the exact same format. Is this clear, everybody? This is really important. ये आपको अच्छे से समझ आ जानी चाहिए. So before moving on, perfect. Aliza and Ramin, is this clear? This is a very crucial concept. People do mess this whole thing कि यहाँ पे bytes है bits है, so it's really important that you identify that we are talking about bytes or bits. So now we are done with yeah. Okay, so we do have one last part again related to chapter number one, which is related to compression. It's a one marker, and it's only asking us why should there is like basically a photographer who wants to compress her image, and now it's asking us why should we be basically compressing the file. So what could be one benefit of compression? Say so we studied like multiple examples that day, maybe to reduce the file size, maybe reduce the storage space required, maybe reduce the transmission time, maybe less bandwidth is required for transmission. So you can write any of them. You have multiple options. So I would go like maybe it reduces the file size. It reduces the file size for storing the image. For storing the image, and you're going to get a perfect one-on-one for this. But apart from this, you could also talk about how you can have lower transmission, so what do we call it, faster transmission, faster faster transmission, and maybe other points related to how less bandwidth might be required and all that stuff. So once you start doing practicing of official past paper, you're going to observe that, okay, now we can also write faster transmission and all those other points. But at this point, because we don't have a lot of time, I'm just going to give you guys a quick overview and we're going to continue. So now we are done with Feb March के papers. Now we would be basically, let me see, इसके अंदर कोई और तो वो नहीं है. I don't think so कोई होगा. Yeah, I don't think so. So we're officially done with the Feb March 2023 ka paper. Yay! Now we're going to be starting off with summer 2023, which is basically your May June session. Okay. So now in your May June session, we have a whole question related to binary conversion, which is a pretty good question, and we will be solving that now. So yeah. So I want you guys to be a bit active, and if you guys feel like I'm making a mistake, jaldi se mujhe phir point out kar lena, sahi hai? It's really important. I can also make mistakes. So we now have to solve this question where we need to convert binary number to hexadecimal. Now this is basically May June 2023 paper number. I guess it's paper 12. I have to see. Wait. Yes, this is paper number 12. Okay. So now we need to basically solve this question, which is dealing with conversions. So when it's dealing with conversions, we in the first part, it's asking us that, bro, okay, Ramin already did it. Okay. Let me see. I haven't even started it, but let's see if Ramin is correct or not. Ramin is saying it's 93. So now we need to convert these binary numbers into hexadecimal. So remember, my only step was to basically write the numbers like this, 0011, break them into nibbles, and then deal with them separately. So now you have 101001 like this and 0011 like this, and now you find the equivalent denary separately, 1 2 4 8. So it's 819 and this is 3. So now you combine them and your first answer is 93, which is 100% correct to what Ramin told us. And now Aliza is saying 39. I guess the second one might be having 39 as the answer maybe. So let's see. 0000 as one part and 1101 as the second one. So 1248, 1248. So this is basically 0, and this is 8 plus 4 plus or 4 12, and 12 plus 1 is 13. But because we cannot write 13 up here, we need to basically go to the chart where we had A as 10, B as 11, C as 12, D as 13, E as 14, and F as 15. I always emphasize that whenever you're writing a hexadecimal question answer, always make this table, even though if you're full sure, because I have been thinking कि मैं बिल्कुल सही करूँ, but I used to mess up like the D and a C value. So it's really important you make this table and see that 8 4 plus 4 is 12 plus 1 13. So I'm going to be writing D. So the answer to the second part is basically 0D. So yes, exactly. 0D. Perfect, everybody. Perfect, everybody. Now, you might be wondering, sir, कि यहाँ पे हमने zero लगाना है या नहीं? That's like a very important question. Do we need to put that zero alongside the D? Because generally, we have been studying that zero does not have any value, right? You might be thinking, sir, is zero required? Yes, it is required. Why? Because if you ignore the zero and you just write D, which like even for the computer is only going to be processing D. Why? Because zero does not have any value. But now if I ask you to go the other way around back to the actual value, but you don't have a zero up here, you will only be able to figure out this part. So you would not understand whether we have these zeros or not. So for that reason, if ever in exam they ask you and they give you a scenario like this where you have empty zeros, it's important that you put that zero alongside it to be safe. Now, in some marking scheme, there can be a possibility where they only expect you to write D, but you should never take the risk, because in exam, they always either give 0D, which is the safer option. See, so we need to go with the safer option. So always mention that 0 alongside it too. So yeah, now we're going to be doing the part B, which says that a value is being stored as a binary number in a register. And now we need to perform logical right shift of 3 places. So we need to perform logical right shift, which means that I have to shift each of them to the right, and I have to do it thrice. अब thrice करने का ये मतलब है कि like all of this is going to go to right, but now you have 2 ways. Like one shortcut is कि may either perhaps at this point, unless you don't do a lot of practice, my advice would be that you first write all of them like this, and then you अलग अलग से ना you basically perform a shift and you get the answer. So we need to do it thrice. So this means that this one is going to come up here, this 0 would come up here, this one is going to 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 come up here, this 0 is going to come up here. So we basically move like this, right? So it's like everything shifting towards right. We saw that this 0 is basically going to go up there, but because we don't have a slot up here, it's going to be ignored. So we're going to be ignoring this. Ignored. And just like that, we have an empty slot up here left. So whenever we have an empty slot, we fill it with a 0. So we just performed LSR once, right shift once. Now I'm going to be repeating this again. Now this one is going to go out. So I'm going to get this 0 up this one, followed by this, then this one, then this one, then this one. 1 1 1, yeah. And now this 0 is going to come up here, this 0 is going to come up here, and now again empty slot, a 0 is going to come up here again. And now this means I performed the logical shift twice, but because the question clearly asked me to do it thrice, so I'm going to be doing it one last time, and it will be basically this one is going to come up here, 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 and 0 0 0 0 is going to come up here. So my final answer to this is 0 0 0 0 1 1 1 1, which is 100% similar to what Hassan Abdullah said. Perfect, Hassan. Rami, no. See, I guess you performed it the other way around. We need to perform right shift. So right shift में आप right side पे जाते हो, सही है? And one other shortcut to this is, which I would have done अगर मैं exam में होता, I would have seen कि यार if I want to do right shift thrice, this means कि यार 1 2 3 को छोड़ के this element would be basically moving 3 times. Say this element, this first one is going to be moving 3 times. So एक दफा ये इधर आ जाना, one shift, then it's going to go up here second shift, and then this is going to come up here third shift. So like I know that this one eventually after 3 shift would be up here. So this would be 1, and I'm going to be following the exact same cycle क्योंकि हर एक आगे हो रहा है. So 1 was going to come up here, this one would come up here, this one would come up here, and because I have these empty slots, ये तो 0 0 0 ही हो जाने. So I get the answer as this way too. So both of the methods are correct, but I would recommend that if you don't have a lot of practice, so you should go with this one. This is the safer method and the correct method to figuring out it too. So what's the use of logical shift? Good question. So now the second part is basically exactly asking the same point. That, bro, you tell me, what if I have to, why did I do this logical shift? Like, what's the effect of this? So we studied this in class, that whenever we do a logical shift towards the right side, this means that I'm dividing the value by 2. And whenever I perform a logical shift towards left side, this means that I'm multiplying the value by 2. So now if I have a specific, if I'm, let's say, making a calculator or maybe some calculation, or there is some application in which I need to immediately maybe multiply the value, and I need to double the value, maybe multiplied with 8 or maybe multiplied with 4. So rather than making a whole calculation based on converting each of those values separately and adding them and doing it the longer way, computer scientists figured out that the shortest way is that I could basically perform a logical shift. So I can tell the computer perform logical shift on this value towards the right side, and this would basically half the value or maybe divided by 2. So the use of logical shifts come into existence where I need to immediately maybe divide a value or multiply a value, and I don't want to go with some long coding. So I can tell the computer by left shifter to multiply by 2, right shifter divide by 2. So the same point is asked up here, that you need to give us one effect this logical shift has on the binary number. So because we are aware that the shift has been done right in the rightward direction 3 times, this means my value, first whatever the value up here we had, it was getting divided by 2 once, then it again got divided by 2, and then it again got divided by 2. So if I have to write this in word, I can say that the value got divided by 8. So I can write that the value got divided by 8. So if I have to do a calculation where I might have to divide some value by 8 immediately, rather than writing the whole code to it, I can basically tell the computer perform logical shift right thrice. So now it's easier for us to basically divide and multiply the value. So the main use of logical shift is to perform such multiplication and division calculations at a faster pace. At least at your level, आपको इतना ही पता होना चाहिए कि logical shifts के ये logic है. If a question ever comes up in exam to explain some effect this has, it always has to deal with either multiplication or it has to deal with division. इसके बगैर there is no other effect. सही है? So whatever division, my bad, division. So you only have to write one of these two answers and you would get the correct answer and the appropriate marks to it. सही है? Now समझ आ गई हसन? What's the use? Shifts to the left are multiplication. Yep, shifts to the left LSL are multiplication. Shifts to the right are basically division by 2. Multiply with divide. इसको मैं divide कर ले तो my bad. Divided by 2. ताकि आप लोग को अच्छे से समझ आए. Um, Hassan, because you joined us late, I would also recommend that once you over the weekend, you should also go and watch the leftover recordings because uske andar we did this in great detail. So if you have any other questions, those might also be cleared up after you watch those recordings. Say it. So now we're done with this one question too. Let me see if I have other question. And yes, we do have two other parts of the same question from the May-June series. And this tells us how long of a question this was. And now this one is again dealing with the uses of hexadecimal. And it's asking us that what do you think, why does a specific programmer uses a hexadecimal to represent binary numbers? So when we had a discussion on binary numbers at the first place, hexadecimal numbers at the first place, we did a pretty comprehensive sort of discussion on why hexadecimal figures might be used by a programmer. We discussed the benefits, remember? So now in this question, it is just asking us to list down those benefits. So one was maybe like, क्या कहते हैं, it might help you easily, what do we call it, write it. It's maybe easier to debug, like if I want to find some error and I have to write zeros and 11100, the chances of making an error are also high. So if I'm writing it in shorter form, it is quick, it is something which I can write like quickly. It is something which is easily understandable. It is something where I'm less likely to make a mistake. It is something which maybe takes less space on the screen. So yeah, it takes less space on the screen. So you can write any of them up here, easier to debug. Debug basically means to find errors. So while coding, if there are some problems or some errors on your code and you want to find where am I making those mistakes while coding, so usko debugging bolte. So this is the process. It's more compact. Now you see, Hassan, now the purpose of conducting these classes, these topical classes, is the same. That you just listed a valid point that it's more compact, but you won't be getting marks for it. Why? Because it's a vague statement. The examiner might award it, but according to the marking scheme, a lot of students, like in the last batch when I gave them this assignment, a lot of students wrote the point that it takes less space, which might be correct, but it's 100% incorrect because of one reason. Do you know what? And that the reason behind that is basically it does not take less space in the memory. It takes less space on screen. So the way Ramin mentioned, if you want to talk about that point, you would say that it takes up less space on screen, and this would be basically 100% correct. अब किसी बच्चे ने, if someone just writes that it takes up less space, the examiner can assume that you're basically talking about storage, and it's irrelevant because in the storage everything would be in binary. So even if you write a code in, let's say, A7B8, this eventually would be converted into binary. So in the memory it won't be making any difference. The only difference would be that when on your screen, rather than A7B8, if I write it in binary, it might be taking this much of a larger chunk, which it's not taking right now. And that is the main difference. It's the main factor that's making the difference. So uske baghair ye ke, what do we call it, this is one valid point to it. Apart from that, now if I look up at question number D, it's saying that I have a denary number and I need to convert this into hexadecimal. So my approach, remember what my approach was, convert this denary number into binary and then go from binary to hexadecimal, because that's the way where you might have the least possibility of making an error, and it's either way you're going to get marks for it. So don't worry. So how would I be converting 301 into binary? binary, I would be writing the values up here: 1, 2, 4, 8, 16, 32, 64, 128. Now you know that the maximum I could have for a 2 8-bit register is 255. But now because it's 301, I need to go to a larger register. So this has to continue: 256, 512, 1024, and 2040. And now I have to basically fill it up here. So this would be a 0, this would be a 0, this would be a 0, this might be a 1. So now I need to add something into 256 that can get me 301. So can it be 128? No. Can it be 64? Let's add up 256 into 64. This is basically 0 with 1. And this 66 is basically 2. And this is basically 320, right? That's also going to be no. This could be a 1. Why? Because 256 plus 32 is basically 2. This is going to become an 8. This is 8 and 288. Yep. Now 288 plus 16 is basically going to be 6 plus 8 is what? 214. One is going to come up here: 8, 9, 10. This would be 0. A 1 comes up here: 304. Again greater, this has to be 0. So this means now I have to turn on 288 plus 8, which would be what? 290 and 296, right? 296. And that's fine. 296 plus 4 is basically 300. And then 300, I'm going to be putting 1, so I get the answer as 1. So this will be 1, 0, and this will be again 1. So this is my binary for it, right? I get the binary from here. And now if I have the binary and I want to go from binary to hexadecimal, you're going to see that I would be basically figuring out the nibble. So a group of 4. So starting from the most right hand side, one group, 1, 2, 3, 4, one group. And because it's 12 bits, so 1, 2, 3, 4, another group. Say, so now we have 3 groups and I'm going to deal with them separately. This would be now 0, 0, 0, 1, and I'm going to be finding separately for this. This would be 0, 0, 1, 0, again separately for this, and then 1, 1, 0, 1 separately for this. So now you see this would be only 1 because it has 1 as the only on state. Then up here it will be 2, and this will be 8 plus 4, 12, and 12 plus 1 is 13. But now we cannot write 13 up here, so we will go and refer back to the table. So rather than rewriting, we wrote it up here. 13 is basically a D, so I would be writing D right down up here. So my answer to this question is basically 1, 2, and a D. And let me confirm it too, but this will be the right answer. Yes, it is the correct answer, alhamdulillah. So now is this clear, guys? Everybody in the chat box quickly, or do you have any questions regarding this? This is a shortcut which I discussed. Usually there is one other method, 301 to convert. It's basically multiplying it with 16 raised to power something. But I don't recommend that method because the chances of making an error with multiplication with 16 is pretty high. So why go with a method which can include the chances of errors, right? Go with the easier one. So always when you get a question like this, convert it into binary and then convert that binary into hexadecimal, and it's going to be way better, right? So we are done with this question too. And now we have this one very good question which I also have. I did not see this question before, but acha chalo, let's do this one question. Let me just take the whole screenshot of it and paste it up here. It's basically related to ASCII values. So yes, so remember the whole discussion we had of how you type a specific button and it comes up on the screen and all that discussion. We're going to be dealing with the same question up here. So it's basically related to how the text is converted to binary, that it could be processed by the computer. So now this question is again from May June paper number 12. So you see May June series, the one which you all would be giving inshallah. This question says that now describe in a 3-marker answer how can we basically convert the text into binary so that it could be processed by the computer. So there is a clear-cut 3-mark step answer to it. The first one is that your computer has a table. Remember, I created that one. I showed you that image that A has a specific binary value, B has a specific binary value, and it has the name of character set. So we're going to say that a character set would be used, and we have to then tell, like, give an example like a character set like a Unicode or maybe ASCII, and then each character within that set is basically having a unique binary value which allows it to have separate binary values for each of the digits. So I'm going to be writing like this: a character set will be used. A character set will be used. You will get 1 mark for this. Then you need to tell such as ASCII or Unicode. So yeah, you get the 2nd mark for giving the example. And then you need to basically tell them about how each character has a unique binary value. So I'm going to say each character has a unique binary value, has a unique binary value. and you're going to get a perfect 3 on 3 for this. Now you might be wondering, sir, itni jagah diye, why are we not filling it up? So remember, when a question like this comes up, you also always have to look up at the marks. 3 marks equals to 3 statements. No need to overwrite points, unless if you have 1 point and you want to be at the same place. So you could write like maybe 4, but only like in a question where they do not specify. So like at this point, if I was in exam, I might have also explained one other thing that maybe I could have talked about. There is no relevant other point, but if like something pops up in my mind, I would have written it just to be on the safe side. Say now it says in question part B that text that is basically an input to the computer can be stored in a text file, and that the text file can be compressed using lossless compression, the one which we studied last night, right? So now it says that state what effect does this have on the file size. So we basically need to tell that when we make use of a compression, what effect will it be having on the file size. So we are all well aware that when we do compression, it basically reduces the file size. So reduces the file size, and you're just going to get the mark for writing this one statement. And now this is a 4 marker perfect question asking you, how does the lossless compression work? So we need to explain the whole process of how our compression algorithm is used, and then we can give an example such as an RLE, which we discussed last night. And what happens in RLE is that repeating words, or maybe I can say patterns, are being identified, and then they are basically written as if with the number of with maybe like the index number, like not the index number. You can basically say that once the patterns are identified, we can write it alongside its index number with the number of time it has occurred, or maybe with their position. So like I can say that the first position wale number one position pe jo bhi hai, it is being repeated 5 times. So like the way we did that, if A, B, C, C, D hai, so I could say that this was A, then this was B, then 2C, then 1D, and so on. So yeah, so we could have explained it this way. We can also give an example, like when I had a question like this, I used to give example. But now example is not something expected from you all up there, but you can write it. Say so. First of all, we're going to be writing how a compression algorithm will be used. A compression algorithm will be used. Algorithm will be used, such as run length encoding. Run length encoding. Now, this exactly makes up with the point which I was discussing last night, that run length encoding is one method or one algorithm which lossless compression uses. So you might have other methods which maybe WinRAR and all those other things you might be using. So ये नहीं है कि सिर्फ RLE है, सही है? And now what RLE does is that patterns are identified. Patterns are identified in the text file. Identified in the text file. Text file, and are then written and are then indexed and written alongside and written alongside the number of time it has occurred, the number of times it has occurred, and you're going to get a perfect 4 on 4 for writing this. 4 points, 4 marks. You could also talk about maybe with their position. So I could also write this 1 point with their position, and this would be like basically 5 correct points. And so now if one of my points beforehand was maybe vague or something, I'm not going to be at risk, because agar ek cut bhi jata hai, so examiner will say that okay, this person wrote 5 points and we did not specify to write 4 points, so he should be good to go. We're going to award him the marks. See? So this is the exact perfect answer you can write for your lossless compression model. Aapne ye sare points karne in exam. They are expecting you to write this compression, an example, patterns wali baat sahi hai, then this indexing, and maybe the number of time it has occurred, this, and this position. So these are the keywords which the examiner expects you to write. So like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 6. Okay, maybe I wrote 6 points. So yeah, so I wrote like 6, but you can write any 4 of these to get perfect answers. Say. Now then, in the last part, it's basically asking us give 2 reasons why the text file may have been compressed. Now, in this scenario, we don't have a scenario up here, but usually in a question like this, you need to basically tell them the answer in terms of either the scenario, or agar let's say we don't have a scenario, to aapne general form mein bata dena hai that why are we going to be compressing the file. maybe to save storage space, right? To maybe quickly transmit it. So यही दो valid points है. You can also say that to make it small so that it could be transmitted with an email, or maybe to reduce the bandwidth needed to transmit. So the easier one are basically to save storage space and to make to quickly transmit it, to save storage files, storage memory, and second will be to quickly transmit the files. Transmit the files. And you're going to get a perfect 2 on 2 for this. 2. And this marks the end of questions from your chapter, from your, what do we call it, May, June 2023, paper number 12. Before moving on, everyone quickly in the chat box, is this clear or do you have any sort of questions related to it? If you do have, pucho. Perfect, Hassan. Everyone else? Clear, or anything which is not clear to wo pucho. That's great. That's great. Now we are done with summer 23 ka paper. Now we would be basically looking into summer 2023 paper number 11. So yes, so we're going to observe paper number 11 Q questions. So let's do this one question. This is now from May, June 2023, paper 11. So it's basically, again, a very straightforward basic question. And this asks us to deal with binary conversion. Say, so you double okay, my bad. So let's solve this now. So this is from your summer, May, June 23. Paper number 11 says, so the previous one was from paper 12. This is paper 11. It says that binary is a number system used by computers. Tick one box with statement about binary number system is correct. Is it a base what system? So we are well aware that binary has only two states, 0 and 1, because it can have only two possible answers. This means it is a base 2 number system. So the answer to this is basically B. Then continuing, we now have question number part B, which says that binary numbers are converted to binary number to be processed by computer, and we need to basically convert them. So I won't be wasting a lot of time. Let me just do one of the example. Let's do 102. So how do you do it? You basically write the values 1, 2, 4, 8, 16, 32, 64, 128. Each of these value is basically for the specific position. If you don't understand this, the videos for chapter number 1 have been posted on our YouTube channel too, and we are available to you guys on your Google Classroom too. And you guys should go and rewatch that to understand what I mean, that each value has a specific, like each of these slot has a specific value assigned to it. Now I need to just place ones beneath all of those values, which when I later on add them, I should be getting 102. So it's basically, this would be 0. Why? Because 128 is greater than 102, not possible. 64 would be on. When I add 32 into it, it becomes as 96, right? And then 96 ke andar I need to add maybe 4 and 2, right, to get 102. So this means that I could keep this 0, 0, 1, 1, and this again 0. So this is basically how you convert your denary into binary. I don't want to waste time on the other two. So 0, 1, 1, 0, 0, 1, 0. Yes, Hassan, bilkul. Remember, tooth complement, we studied a lot of discussion. We had a pretty good discussion on how you can sort of write negative integers in your answers. So now you see that we have binary numbers which are stored in register, and we need to basically oh, I lost the internet connection. Shit. Apologies for that. Yes, I got disconnected. Can you guys hear me clearly? And also, is the screen visible? Hello. All right, good. कितने टाइम पहले डिस्कनेक्ट हो गया था? I haven't started this question though, but did you guys get it till this 102 wali logic? Okay, that's fine. Maybe 5 seconds per masla nahi. Okay. So now we're going to be starting off with this question, which is basically dealing with negative numbers. Say, so 2's complement concept. So like we did study how I can represent positive 102, but what if I have to represent negative number, right? Now I have to do negative 78. अब वो मैं कैसे करूँगा? For this, we need to use the 2's complement concept. Now they clearly stated it up here, 2's complement. So how do you go with 2's complement? You first of all, method behind this is that you're going to be writing the binary for positive 78 first. So let's do that. 1, 2, 4, 8, 16, 32, 64, 128. And let's write the binary for positive 78, which would be 0, 1, 0. This would be 0 again. This would be basically 1. And then this would become as well 72, 76, 78, and 0. So now this is basically positive 70. Now to get the answer in terms of negative, I first have to flip the bits. When I flip the bits, this means that 1 is going to become a 0 and 0 is going to become 1. So 0, 1, 1 will become 0, this will become 0, 0, this 0 will become 1, this 0 will become 1, this 1 will become 0, and this 0 is going to become 1. Now this answer at this point is basically in terms of 1's complement. 1's complement. And now when I get into 1's complement form, at this point, this has this one feature that when I do a 1's complement thingy, now it is in terms of negative numbers. So अब इसके अंदर negative वाला pan आ गया. Now rather than this bit being positive 120, this bit is now representing negative 120. But because the answer the examiner requires us is in 2's complement form, and also to now get from 1's complement to the final 2's complement negative form, because negative numbers are always in 2's complement form, I would be basically adding 1 into it. I would be adding 1 into it. So now I would be using the binary rules which we studied earlier on to basically add these figures. So 1 plus 1 is basically what? Remember the rules? 1 plus 1 is 0 with a carry, right? So 1 plus 1 would be a 0 with 1 carry up here. And now we don't have anything up beneath this, so this is basically going to be 0, 0, 0, 0, 0, 0, 0. So now 1 plus 0 is again the same thing. 1 plus 0 is what? It's basically a 1. So this 1 is going to come up here, and then all of these other things are just going to be like this: 1, 1, 0, 1, because 1 plus 0 is 0 and 0 plus 0 is 0 either way. So we get the final answer as 1, 0, 1, 1, 0, 0, 1, 0. And now this is representing negative 78. This answer is basically in terms of 2's complement. Let me confirm it too, whether this is correct or not. I hope it is. It is basically going to be what? What question is this? This is basically question number 1C, right? So 1C is 1011 and 0010. Yes, we got the right answer, right? So we should be good to go. Now we would be basically again dealing the question with the binary addition. Now this is a pretty good question because this is the maximum most difficult question that could be tested from chapter number 1, binary calculations. This is something which a lot of students hate, so I would advise कि ये चीज आपको अच्छे से आनी चाहिए, and it's not that difficult. You just need to understand the concept and then apply it in the right way. So now right now we just need to add them. We need to use the same rule. 0 plus 0 is 0, 0 plus 1 is basically 1, and 1 plus 1 is basically 1 with a carry. And if we have a scenario where we have 1 plus 1 plus 1, it means 1 plus 1 carry. Okay, so these are the rules. If you don't understand them, you can go and watch the recording for it, and आपको अच्छे से समझ आ जाएगा. We also did a lot of practice back then too. So now let's apply them up here. You see 1 plus 1 is basically this is 0, my bad, this is 0. So 1 plus 1 is basically 0 with 1 carry. This carry goes up here. Now this is again 1 plus 1 plus 0. It's the same way if I say 0 plus 1 plus 1. So it's again going to be 0 with 1 carry. Now up here 1 plus 0 plus 0, it's the same way I say 0 plus 0 plus 1. So 1 plus 0 plus 0 is basically 1. I get 1 up here. Then 0 plus 0 is going to be 0. 1 plus 0 is going to be 1. 1 plus 1 is again going to be 0 with 1 carry. And now 1 plus 0, 1 is basically 1 plus 0 plus 1 is again going to be 0 with 1 carry. And now 1 plus 0 is going to be 1. Now I get my answer as this: 1, 0, 0, 1, 0, 1, 0, 0. So let me confirm it again: 1, 0, 1. 1 0 0 1 0 1 0 0. Yes, perfect. That's the correct answer. So yes, so we have also done this one question. And now the biggest problem with binary addition is that usually not in this case, but in some occasions when you add them, we get an answer in the 9th bit. So like when we were doing it back in the class, we had an example where we got a scenario where maybe if I have this something like if I have the number up here as 1, like imagine this was 1. So 1 plus 1 plus 0 is what? 1 plus 1 plus 0 is basically 0 with 1 carry, right? So if I might have a carry up here and we don't have anything, this is going to go into the 9th bit section. So now this results in an overflow error. overflow error. And not, this is something which is not happening up here, but what if a scenario like this comes up? So in that scenario, we have an overflow error. And now the last part of this question is asking us that what if an overflow error occurs, and like you just need to explain why does it occur. So you need to give 2 points to it. The first point is that your overflow occurs because you went into the ninth bit. Now going to the ninth bit means that you're exceeding the maximum possible value of the 8 bits. So a register of 8 bits can maximum have the value of 255. This means that when you're exceeding 255, you're going to go into the ninth or maybe upcoming bits, which means an overflow error might have occurred. So एक तो point आपने ये लिख देना है कि the result of the calculation is greater than 255, and then you need to say that to overcome this, you basically need to have more than 8 bits. So you can say that the calculation would require more than 8 bits to be represented. Say, so I will say the result of the calculation, the result of the calculation exceeded the max value of 255, max value of 255. 1 point, 1 mark for this. And so for this calculation, more than 8 bits are required. More than 8 bits are required. 8 bits are required for its representation. Now I remember that a similar, perhaps I guess the same exact question was given in the practiced assignment which I gave to my students of the October-November batch, and a lot of students got 1 mark in this question where they told us that okay, you need to have more than 8 bits, which was one right point, but they were unable to figure out कि यार आपने 255 वाली बात भी करी है. So do keep this in mind that if a question comes up, you need to talk about both the value as well, like how many bits you might be requiring. Say, so it's not necessary कि 8 or 255, because we had a scenario which included 8 bits from the first part. So इस वजह से यहाँ पे भी we are going to be dealing with it in the same way. And now we have this one last question before ending the class. I would try my best. Perhaps ye ho hi jayega, inshallah. This is again related to your, what do we call it? Compression and sound files. So acha, we will also cover sound files too. And now this question says that we have a student has basically a sound file that is too large to be stored on this secondary storage device. Okay. And now the compression method uses it, it basically reduces the sample rate and the sample resolution. Now you tell me, what type of compression method is this? It is basically reducing something, right? It is reducing the sample rate. It is reducing the sampling resolution. So now the good point about our class content which we discussed last night was that we clearly mentioned up here, ye dekho, that if there is a lossy compression, this means we're reducing sampling resolution. So this clearly indicates that basically yahan pe bhi sampling resolution hi kam ho raha hai and sample rate. This means that we are dealing with what? We are doing lossy compression. This is lossy compression. And now it says that you need to firstly define what is sample rate and what is sample resolution. So आपने बस उनकी definition कर दी, perfect Hassan, बिल्कुल, it's lossy compression. So you need to basically give them the exact definition. So your sample rate is basically the number of samples taken per second. So the number of samples taken per second. Samples taken per second. And then the second question part says that you need to define sample resolution. So sample resolution refers basically to the number of bits per sample. Achha, say it is the number of bits per sample. And we are good to go with this part too. And now the last part basically say identify which type of compression has been used. Now they did not say explain, they did not say describe, they just stated the word identify, which means one word or maybe like one phrase. No need to explain, no explanation required, no explanation required. So यहाँ पे you don't need to give them a reasoning why lossy compression. So yeah, so we did identify this earlier on that the compression this would be including here is a lossy compression. So I would be just writing lossy alongside compression. And the moment I do this, I would be getting 1-on-1 for this too. And with that, we have completed one other paper, which is basically summer 2023 paper number May-June paper number 11. Yeah, let's go. So we did three papers in this 1 hour. Comprehensively, we discussed around how many questions? Let me count. We did one, we did two, we did three, we did four, and we did five and six. Okay, so we did around six question, which is pretty good. It's 9:59, and we have completed this one other question too. Everybody, quickly in the chat box, did you guys understand each of the question we discussed today? The logic behind them. What was the approach of the examiner up here? What did they expect us? How we can write the answer? And is there anything out there which you might feel like is not clear? अगर कुछ भी ऐसी चीज है, you don't need to worry, just let me know so that I could explain the topic to you guys. So it's really important that you guys get the concept. I just need to get used to the technical terms. For that, see, you are talking about these stuff, right? So I have one resource for you. Let me open up the book for you. And in the book you have, just give me a second. So let me open up the book. So that's great to know, Aliza. Let me screen share the book. So right now you guys can see the book, say, yeah, and in your book, once you go to the end of a topic, I would recommend that, because now we have completed chapter one, go give it a read. Give it a read so that your concepts are re-revised and it's even furthermore clear. And at the end of the topic, you're gonna see that we have all the key terms discussed up here. So you guys just need to read this like maybe 2 to 3 times, and आपको कुछ ना कुछ idea हो जाएगा. Now you see the exact question about sampling resolution. See, it's discussed up here. Sampling resolution. What's a bit code? What's color depth? See, so we were asked about sampling rate. No, we were asked about क्या क्या पूछा था? Let me open up the question. It was sample rate and sample resolution. So sample rate is this, sampling resolution, and sampling resolution is up here. So you see, then pixel, see, it is the smallest element used to make up an image on a display. And I wrote this display as screen, right? So either way, there can be a bit differences, but most of the time, it's the best place to get the common definitions and the common key terms, which the examiner might ask you to give a definition for. So it's not necessary to basically memorize all of them. Just give them a read once or twice so आपके जहन में बैठ जाए what it's talking about. Okay, and then in exam you can also make it up from your own. I would advise that if there's some common word like these, sampling, resolution and stuff, memorize them perfectly. But if there is something like, let's say, what is bandwidth, तो बस थोड़ा सा आपको idea होना चाहिए. Bandwidth refers to like the maximum rate of maybe a network to for the transmission of data from here and there and all that stuff. So this is one other thing you should be keeping in mind. And with that, we are officially done for today's class, officially completed chapter number one. Alhamdulillah, the recording would be posted. And alongside this, listen up everyone, we would be posting 2 additional videos. We conducted a past paper topical session before starting this December session. And in that, we did 2024 and 2025 K questions. So I'm not sure, maybe a few 2023 questions too. Now, I would be sharing that recording with you all too. And I want every one of you to go and watch those recordings too. Because once, like the way we did 6 questions today, we also did 6 or 5 questions in the pre-2023 set, which is uploaded. And we will also do like 5-6 questions in those recorded lectures too. So those are like 2 videos. So you have altogether around 14 to 20 questions. There won't be a class tomorrow because I want to start chapter number 2 from Monday. From tomorrow till Sunday, you have time to watch those topical session recording, cover up any leftover recording. If you were someone who had their midterms going on, or maybe you guys joined late, go and watch those recording. Reach out to me if anything is not clear, so that from Monday we all can continue from the same pace. And inshallah, in the next week, you would be provided the first practice quiz. Again, these are not quizzes for your feedback or something, or where I would be expecting you guys to give me proper answers. It's just so that you would be it's just so that you guys could understand how to write the answers in the right way. So yeah, Hassan, yeah, it does not matter. IGCSE O levels 100% same thing. If you have an option and you could go with either of them, I would recommend going with IGCSE then. Either way, it's not going to make any difference. IGCSE is just something which a lot of schools are now shifting towards, because it's defined for the international students. So if you're like someone who is taking GCEs internationally, like we are in Pakistan, so now Cambridge has introduced IGCSE for them, international GCSEs. Okay, so it's not going to make any difference. Everything is 100% same. You are at no disadvantage if you opted for O levels or IGCSE. But if you have an option, I personally did IGCSE, and I know a lot of schools are now shifting towards IGCSEs too. So if you have an option and koi masla nahi hai, so I would recommend going with IGCSEs. Otherwise, it's not going to make any sort of difference. Both are 100% same. Even the paper for computer science at O levels and IGCSE level is 100% same. हाँ, बाकी subjects में differences exist करते हैं, but for computer science you don't have any difference. सही है? So with that, everybody, given considering everything is clear and you don't have any sort of other questions, it's 10:04. Let's end the class for today. Inshallah, see you guys on Monday. The recordings would be shared, inshallah, in the Google Classroom portal. And if there is anything not clear, you guys could always reach out to me in my DMs. And I have opened the group too for you all to send messages or any questions regarding the class or maybe the class content. So sab achhe se ho jayega, inshallah. Don't worry, everyone. See you.